Now I am going to be explaining the communication between two neurons and the process of neural transmission. So, an axon originally starts at a place of resting potential where the positive sodium ions are on the outside and the negative potassium ions are on the inside. The axon surface is very selective on what it lets in and what it keeps out. That's called being selectively permeable. So, when a neuron fires an impulse called action potential, which is a neural impulse that travels down an axon. So this is action potential traveling down an axon. The first bit of the axon opens its gates and lets some sodium in with its potassium, which is a big deal, because then that triggers the next section of the axon to depolarize, it causing a domino effect so that every single axon is having sodium come in. During the refractory period, a resting pause, the neuron pumps the positively charged sodiums back outside, so then the sodiums leave during the refractory period. Then the neuron can once again fire again. So, signals that trigger this action potential can be either excitatory or inhibitory. When the excitatory signals minus the inhibitory signals exceed a minimum intensity or threshold, the level of stimulation required to trigger a neural impulse, an action potential is triggered. Back to, if we look down here, the synaptic gap and a neurotransmittal vessels, which are these little blue things. So these neurotransmittal vessels contain neurotransmitters within them. So when the action potential goes through a terminal branch in the form of a synaptic vessel, through the process of exocytosis, the process of secreting vessels out of the cell membrane, the vessels release the neurotransmitters, so it releases the neurotransmitters that it has, that fits into the gaps of the postsynaptic receptors, so then the neurotransmitters go and fits in here. And the excess neurotransmitters that go through the process of reuptake, or they're reabsorbed back into the original neuron because there are no more postsynaptic receptors to receive them. Thank you.